Welcome back to the deep dive. Today, we are strapping ourselves into something that shakes a lot.
Think of a bulldozer rolling over a quarry, or maybe the intense kickback from a pneumatic drill.
Exactly. We're diving into occupational vibration exposure. It's this unseen, repetitive energy that hits millions of workers every single day.
It is, and our mission for this deep dive is to really unpack that. We're looking at the physics, the very severe health consequences,
Things like hand-arm vibration syndrome and chronic back pain.
and also the surprising complexity of trying to regulate and control it all.
So let's start at the very beginning. What is vibration, fundamentally?
It's an oscillatory motion, something moving back and forth, transferring energy.
But for our purposes, the regulators, like the ILO, have a much stricter definition, don't they?
They do. They call it any vibration which is transmitted to the human body through solid structures and is harmful to health or otherwise dangerous.
And that harm, as our sources lay out, really splits into two big problems.
That's right. You've got hand-arm vibration, or HAV. That's from gripping a tool,
And then the other one, whole body vibration, WBV.
which is the energy that comes up through the seat you're sitting on or the floor you're standing on. Two very different pathways into the body.
Okay, so to understand the damage, we first have to get our heads around the physics.
It helps to think of that classic school experiment. You clamp a ruler to the edge of a desk and you pluck it.
And it waggles up and down.
Exactly. That oscillation is what we're talking about. It starts at its maximum displacement, accelerates down through the middle, overshoots, and just keeps repeating that cycle.
And that cycle gives us three key terms to describe the vibration.
Three of them, and they're all linked. First is displacement. That's just the distance, how far it's moving from its resting point.
Then you have frequency, which is how fast it's doing that, how many cycles per second.
Measured in hertz, yes. But the one that really matters for health, the one that measures the damage, is the third one, acceleration.
Acceleration. So the rate of change of velocity. Why that one? I mean, if I'm holding a jackhammer, isn't the distance the handle is moving what I feel?
That's a really good question, and it gets to the heart of it. You see the displacement, but it's the acceleration that really measures the force being pushed into your body's tissues.
So high acceleration means high stress.
Extremely high stress. And because that acceleration is constantly changing, up and down, we can't just use a peak number, we use an average.
The root mean square, the RMS acceleration.
Precisely. That RMS value is the standardized way to talk about the magnitude or the intensity of the vibration.
So acceleration gives us the magnitude, but a tool doesn't just vibrate in one direction, does it?
No, almost never. A complex machine vibrates in 3 dimensions. We call them the X, Y, and Z axes.
Up and down, side to side, front to back.
And you have to measure all 3. The overall vibration a person receives is the combination of those directions.
Which brings us to the most important principle in all of this, the vibration dose.
Yes. It's not just about how intense the vibration is.
It's how long you're exposed to it. The harm is all about the total energy you absorb.
Exactly. And to make that comparable, it's all standardized into one single number, the 8-hour energy equivalent vibration magnitude.
Or A8 for short.
A8. It's the universal yardstick. It lets you compare, say, 30 minutes on a really high vibration concrete breaker with 8 hours on a low vibration sander.
So you can measure both against the same legal limit.
That's the whole point. It standardizes the dose.
Okay, we understand the energy. Now let's talk about what it does to the human body, starting with whole body vibration.
Right. This is the energy coming up through a supporting surface, a seat, a floor.
And the at-risk groups here are huge.
Oh, massive. We're talking vehicle operators, heavy plant operators, especially anyone driving over rough ground.
So tractors, earth movers, forklift trucks on a bumpy warehouse floor.
Even some aircraft personnel. The list is long.
And the primary health risk, the sources are very clear on this, is back pain. But it's not just a simple ache, is it?
No, not at all. It's much more insidious than that. WBV can cause something called biomechanical resonance.
Okay, what's that?
The human spine, particularly the lower back, has a natural frequency it likes to vibrate at, usually around 4 to 8 hertz.
Like a tuning fork.
Exactly. And if the machine you're operating happens to vibrate at or near that same frequency, the energy gets amplified. It accelerates the compression of your spinal discs and the degeneration of the tissue.
So it's actively wearing out your spine.
That's a good way to put it. Now, you hear anecdotal links to things like vertigo or bowel disorders, but the really proven established link that regulators focus on is that chronic debilitating back pain.
And the sources identify specific vulnerable groups.
Absolutely. Pregnant women, young people whose bodies are still developing, and anyone with a pre-existing back injury, for them, the risks are even higher.
So if WBV is about that slow internal damage to the spine, hand-arm vibration syndrome is?
Yeah.
Well, it's probably the more famous of the two.
And certainly more visually devastating. This is the vibration transmitted directly into your hands and arms from a tool.
And the magnitudes can be off the charts.
I mean, a concrete breaker can easily hit 12 meters in tutorials. Some stoneworking hammers can get up to 30.
And just to remind everyone, we said the legal limit for a whole day's dose is 5 meters in Noyles-Tadalate.
Right, so you can see that a worker using that 12-meter Merger central might only be able to use it for, 30, maybe 45 minutes before they've hit their entire legal daily limit?
Wow. So most common tools put you over that limit really quickly.
Very quickly. And it's not just breakers. It's mechanics using sanders, forestry workers using chainsaws. The list goes on.
And HAVS isn't one single condition. It's a syndrome that hits 4 different systems. Let's start with the neurological damage.
Okay, so this is where you get numbness, tingling, a loss of your sense of touch. It becomes hard to handle small things like buttons or screws.
Then you have muscular damage.
Weaker grip strength. And then there's articular, so bone and joint problems in the hands and wrists.
But the one everyone knows, the circulatory damage, is vibration-induced white finger, VWF.
Yes. And that VWF cycle is just awful. What happens is the arteries in your fingers just spasm and clamp shut.
Cutting off the blood flow.
All of it. So the fingers turn stark white, completely numb. But here's the critical thing the sources point out. The trigger for the attack is usually not the vibration itself, it's exposure to the cold.
So the cold makes the damaged vessels constrict, and they can't open back up properly.
Exactly. And then, when the circulation finally, slowly starts to return,
What does that feel like?
the workers describe it as an agonizing, throbbing, burning pain as the fingers turn bright red. It can be incredibly painful. And in the most advanced cases, that circulation might never fully return.
That's terrifying. And the prognosis is not good. Recovery is slight if it happens at all.
The damage is often permanent, which is why diagnosis is so rigorous. They use something called the Stockholm Workshop Scale to grade the severity.
How does that work?
It has separate stages for the vascular damage, the white finger part, and the sensorineural numbness part.
And they test for it how? I've heard they literally put people's hands in cold water.
They do. It's called a cold provocation test under controlled medical conditions to trigger the blanching. They also do nerve tests to measure how much sensation has been lost.
And we have to underline the aggravating factors. Cold weather doesn't just trigger the attacks.
It actively speeds up the development of the condition, and smoking is another huge risk factor.
Yeah.
So we've seen just how damaging this is. The next logical question is, how on earth does an employer manage this invisible energy?
And the guidance is pretty clear. It comes down to a formal 5-step risk assessment.
Right. Step 1, identify the vibration sources and the tasks. And that has to include working conditions, like whether it's cold.
Step 2, identify who is exposed, paying special attention to those vulnerable workers we mentioned.
Step 3 is the big one. Evaluate the risks. This is where you have to quantify the vibration and estimate that daily A8 exposure for each worker.
Then step 4 is recording your findings, and step 5 is reviewing and revising that assessment whenever something changes.
A new tool, a new process, you have to start again.
So let's talk about step 3. How do you get that A8 number?
You have 2 main ways. The first is to use published data, from the tool manufacturer or from a regulator like the HSE.
But I imagine that data comes from perfect lab conditions.
It does, and that's the big caveat. You have to account for real-world factors. An old, badly maintained tool will vibrate a lot more than a brand new one.
So what's the other, more precise method?
Direct measurement.
Using a special meter.
Yes, a vibration meter or an accelerometer. It's a device with 3 sensors inside to capture the X, Y, and Z axes at the same time.
And you have to place it right where the vibration enters the body.
Absolutely. For HAV, it's right on the hand grips. For WBV, it's on the seat pan or the floor surface.
And the calculation is complex.
It can be, but there are spreadsheet calculators to help. The crucial thing to remember for hand-arm vibration is that you only count the trigger time.
The time the tool is actually working, not just idling in your hand.
Correct. And to make sure the data is scientifically valid, the meter and its calibrator have to be tested and certified every 2 years.
All this rigor is because the legal benchmarks are so strict. Let's use the UK and EU standards. For hand-arm vibration, there's the exposure action value, or EAV.
That's set at 2.5 meters 7 EA plane 88.
What does that feel like?
It's pretty low.
Yeah.
It's the kind of level you might get from using a good quality electric drill for a few hours. You might not even notice it.
But if you hit that level, the employer has to act.
Yes. Action is triggered. You need to start health surveillance, provide training, and actively try to reduce the exposure.
And then there's the hard stop, the exposure limit value, or ELV. That's 5 meter-Martisols for HAV.
And for whole body vibration, the EAV is 0.5 meter ricin and the ELV is 1.15 meter cellophrins.
And if a worker exceeds that ELV,
Work must stop immediately. You have to reduce the exposure to below the limit before they can continue, find out why it happened, and make sure it never happens again. It's a legal line that cannot be crossed.
okay, so if we know a lot of common tools can push you over these limits really quickly, how do employers actually control the dose?
You have to follow the hierarchy of control, and you always start at the top.
Elimination.
Can you get rid of the vibrating process altogether? Instead of using a pneumatic riveting hammer, could you use welding or adhesives?
Or instead of a worker using a handheld road breaker, could you use a breaker attachment on a small excavator?
That's a perfect example of elimination. The next best thing is mechanization, using robotics or remote control machines to take the worker out of the equation entirely.
Okay, but if you can't eliminate the exposure, then what?
Then you move down to engineering and administrative controls. For HAV, this starts with a good purchasing policy.
Buying low vibration tools from the start.
Exactly, and also buying efficient tools. A better tool that gets the job done faster means less trigger time, which means a lower dose.
That makes sense. But maintenance is crucial too, right? I imagine there's a temptation to just use administrative controls like job rotation instead of spending money on upkeep.
That tension definitely exists, but the sources are clear that maintenance is a non-negotiable engineering control. A worn-out, blunt, or poorly serviced tool can vibrate exponentially more. It's a huge safety issue.
And on the administrative side, you have things like job rotation, rest breaks.
And crucially, making sure workers can keep warm and dry. Because we know cold is the #1 trigger for VWF attacks.
Now, switching to controls for whole body vibration, the focus is different.
It's all about the vehicle and the ground it travels on. You're looking for good suspension systems in the cab and the seat.
And maintenance here means things like balancing wheels and keeping that suspension in good order.
And critically, maintaining the roads. Filling in potholes, grading surfaces. A smoother road means dramatically less vibration.
And you also have to train drivers to avoid the bumps and to adjust their suspension seats correctly for their own body weight.
Yes. But he made a really critical point earlier about WBV control.
About personal protective equipment.
That's it. For whole body vibration, there is no effective PPE. You can't wear a special belt or padded boots to protect your spine from that kind of deep, low-frequency energy. The control has to be at the source.
That is a massive takeaway. So finally, what about new technology? Wearable devices that track exposure.
They're becoming more common. And the advantage is obvious. They measure what the worker is actually being exposed to moment by moment.
Which could be more accurate than just using the manufacturer's data for the tool.
It could, and it can provide real-time alerts,
Yeah.
but there are significant challenges.
Such as?
The employer is responsible for making sure the measurements are valid, not the company that sells the device. And then you have the practical issues. Battery life, comfort, durability.
And the human element. Tampering.
Exactly. If a worker's under pressure, they might find a way to game the system, which makes the data completely useless for actually protecting them. It requires a lot of trust.
We have covered a huge amount of ground in this deep dive.
Yeah.
I think the core takeaway for me is that all harmful vibration is measured by that total dose, the A8.
And that's the only way to compare a short, intense exposure with a long, low-level one against the same legal standard.
We also understand that critical difference between HAVS, which causes that terrible cold-triggered vibration-induced white finger.
And WBV, which slowly compromises the spine through that biomechanical resonance.
And we know the regulatory bottom line. Hit the action value, and you have to act. But you must never, ever exceed the limit value.
That's the hard stop. Now, the sources are consistent on one thing. HAVS symptoms are progressive, and recovery from the vascular damage from VWF is minimal to non-existent.
And we know that cold and smoking are major aggravating factors.
Which brings us to our final provocative thought. For any individual worker, even if their employer follows the rules perfectly and keeps their exposure below the legal limit, which is set to minimize, not eliminate risk, how much rests on personal control? How important are lifestyle choices, like not smoking, or environmental factors, like keeping warm, in preventing what could be lifelong irreversible health damage?
What is the limit of occupational safety? when a cold, damp day is the main trigger for a debilitating and painful circulatory attack.